represent linear equation in two variables graphically. Students, in the previous section we learned about the algebraic method of obtaining solutions for linear equation in two variables. Since linear equation in two variables has infinitely many solutions, we will plot as many points as we can and see how its graph looks. So here we are going to use plotting a point in Cartesian plane, which we learned in chapter on coordinate geometry. Say we get x1, y1, x2, y2, x3, y3, etc. are solutions to a given linear equation. Plot the points x1, y1, x2, y2, x3, y3 on graph paper on a suitable scale. Join the points after that. You will notice that you get a straight line. That is the reason we call this linear equations. For example, let's draw the graph of the equation. Y minus x is equal to 2. Let us rewrite the equations. Y is equal to 2 plus x. Now, we put different values of x and see what values for y we get. For x is equal to 0, y is equal to 2 plus 0, which equals to 2. For x is equal to 1, y is equal to 2 plus 1, which gives us with 3. For x is equal to minus 1, y is equal to minus 1 plus 2, which gives us with 1. And for x is equal to 2, y is equal to 2 plus 2 is equal to 4. Now, for making a graph, we have enough number of points. So we draw a table first. This is what we get. Now, we plot the points 0, 2, 1, 3, minus 1, 1, 2, 4 on the graph paper. Now, the point to note here is when we join the points plotted on the graph, what we obtain is a straight line. You can see the same given here. This is something we mentioned earlier. A linear equation in two variables represents a straight line. Each point on a straight line is a solution to the corresponding linear equation. Now, if we keep on extending the line from both the ends straight, we can have infinite points lying on the line, which confirms there are infinite solutions to a linear equation. For example, draw the graphs of equations x is equal to y and y is equal to minus x. Also, find the point of intersection of the two lines. Step 1. For x is equal to y, where x is 0, 1, minus 1, 2, minus 2, and y is the same. Step 2. For y is equal to minus x is 0, 1, minus 1, 2, minus 2, where y is 0, minus 1, 1, minus 2, and 2. When we plot the graph for both the equations on a graph paper, we find that the lines are intersecting at the points 0, 0. Again, both these lines have infinite solutions represented by the infinite number of points on them. Students, the x and y axes are also two straight lines if you look at it carefully. These two lines are used as the reference for plotting other points, lines and curves. Now, if I ask you to write the equation of x-axis, what will your answer be? Okay, let me help you. If we write examples of points on the x-axis, we will get an idea as to what its equation could be. Let us see, there is 1, 0 and 2, 0, 3, 0 and so on. Minus 1, 0, minus 1.5, 0, etc. are points lying to the left of the y-axis. But what is special about these points is the value of y-coordinate. Can you guess what it is? Yeah, it is 0 for all these points, and x-coordinate can assume any real number value. So the equation will be y is equal to 0. Clearly, y is equal to 0 implies there are infinite possible values of x-coordinate for this line. The infinite solutions will be 1, 0, 2, 0, 3, 0, 4, 0, and so on till infinity, 0. Alright, now try to write the equation for y-axis. I'll give you some time to find your answer. Till then, I can tell you that it is going to be a similar kind of an equation as the equation for x-axis. Alright, time's up. This is the answer. X is equal to 0 is the equation for the y-axis. It is made up of infinite number of points that have their x coordinates equal to 0. That is 0, 1, 0, minus 1, 0, 9, 0, minus 9, 0, minus 2.75, etc. all lie on the y-axis. We note that in these cases, one of a and b is 0. The general form of a linear equation is ax plus by plus c is equal to 0. In the equation for x-axis, y equal to 0. The value of a and c is 0 and b is 1. Similarly, the equation for y-axis has b and c equal to 0 and a is 1. Let's see what happens when we change the value of c in these equations. Let us draw graphically the line y is equal to 4. Let's write it in the standard form, that is ax plus by plus c is equal to 0. 0x plus y minus 4 is equal to 0. C is minus 4 here. While finding points on this line, we have to remember that y coordinate can only be 4. The x coordinate can be any number. So we have points like 0, 4, 1, 4, minus 1, 4, 2, 4, minus 2, 4, etc. On plotting these points on the graph, we get this line. We see it is parallel to the x-axis. It sits at a distance of 4 units from the x-axis. If you remember, y is equal to 0 represents the x-axis itself. So, any equation of the form by plus c is equal to 0 or y is equal to minus c by b is a straight line parallel to x-axis and passing through the point 0, minus c by b. For example, 4y minus 9 is equal to 0 is one such equation. It has b is equal to 4 and c is equal to minus 9. It will be the same as y is equal to 9 by 4, which is equal to minus 9 into minus 9 by 4. This is exactly the same as minus c by b for this equation. It will be a line parallel to x-axis at a distance of 9 by 4 units from it. Notice that since the value 9 by 4 is positive, this line will be above the x-axis. Alright, these were the equations with only y in them and they represented lines parallel to x-axis. Let us see what happens with equations of the form ax plus c is equal to 0. If we consider x is equal to 0, which has a is equal to 1 and c is equal to 0, we get the y-axis. If we put different values of a and c, we will get other lines parallel to y-axis. Ax plus c is equal to 0, which implies x is equal to minus c by a. This means that such a line would be parallel to y-axis and at a distance of minus c by a from it. Why don't we take an example here? Examples always help. Say we had 3x plus 8 is equal to 0. This would be the same as x is equal to minus 8 by 3. Now this line would be parallel to the y-axis and will be at a distance of 8 by 3 units from it. Since there is a negative sign before 8 by 3, it will be 8 by 3 units to the left of y-axis. Similarly, whenever a linear equation contains just the variable x on a Cartesian plane, it would be parallel to the y-axis. Students, we have come to the end of this chapter now. In this chapter, you learned about a few equations in two variables. I hope you understand all the concepts covered. And don't forget to check out the games and quizzes we have in store for you. Till then, see you next time.